Hello, my name is Caroline Leps, and I'm happy that you've joined me to watch this quick video that highlights some of the pieces that Meredith and I shared at our Fraction Talk PD this afternoon, in case you weren't able to join us. So, welcome. So, let's dig in. First, what is a Fraction Talk? Fraction Talk is intended to be a short routine that you use often, and students are to learn the routine so that they can focus on the mathematics instead of the what am I supposed to do now. So it's meant to be a mental math routine. You can use visuals, you can use manipulatives with it, but the idea is to get students thinking about the situation and how they would solve that situation. From there, as students work through this short routine, as they're thinking and then sharing their ideas and debating if there are different solutions to the situation or different strategies, they start to develop this really deep understanding of what fractions are and how we use fractions, especially even with operations. Once they've done the mental math portion of it, it then becomes a conversation starter. So solutions are shared, strategies are shared, sometimes debates erupt as we're trying to figure out which is the correct solution or which strategy you might use and why. And as such, students are learning from each other the whole time. It also gives you this great opportunity to gather some formative assessment. Thinking about that triangulation of assessment, this is a great place to listen and capture what are students saying that demonstrates their thinking and their understanding. So to that end, when you look at the outcomes related to fractions in each of the grades, here are some of the verbs that pop up again and again and again. And all of these go so beautifully with a fraction talk. So being able to visualize fractions and then do things like verify, express, relate, compare, identify, describe. A fraction talk is a great tool for all of these. There are 4 foundational principles of math talks, including fraction talks, that I just want to highlight for you before we get into a sample fraction talk. First, that you build a safe learning community, one in which mistakes are honored as a tool to help us understand better, a place where students can have one idea, and then as they start to see how others are thinking, that they can change their mind and they can try something different. That all ideas are accepted and valued and considered. Again, another foundational piece is that the problems are carefully selected. You might be selecting problems so that students are exploring new ideas for the first time, perhaps. Sometimes you might be selecting problems where students are actually applying what they've already learned to a new context. My favorite part is the recording that you as the teacher do. So as the students are talking, comparing, debating through the math talk, through the fraction talk, you are recording their solutions, recording their strategies, making their thinking visible using models and representations so that all the students can see the connection between the thinking and what the math looks like and tools that we could use for thinking. So it's so powerful. And as students see the ways that others are thinking, they start to add to their own toolkit of strategies that they can use when they come across similar situations. One of the challenging pieces, but one that's worthy of noting, is knowing when to ask and when to tell during a math talk. It's very, very tempting to just show kids how to do it. If you have the ability to ask questions that deepen their thinking, to clarify their thinking, or to even throw the question back to the whole class so that other students have a chance to answer, it's far more powerful. So keeping in mind that safe learning community, one of the tools that is common for number talks that works well for fraction talks is the use of hand signals. So for some of you, this may be familiar. If not, I'm just going to quickly demonstrate them, and know that you can vary these just as long as you use them in the same way with your students all the time. And so I typically do a closed fist at the heart to indicate thinking. My expectation is that all students are thinking at the beginning when the problem or the situation is posed. Providing lots of wait time. Then students might start to put up a thumb. A thumb up means that they have an answer or a solution. The reason we're doing it at heart level is it lets you as the facilitator see what everyone is thinking or where they are at in their process, but it doesn't have students stopping thinking because someone's put up their hand and it's like, okay, I don't need to answer anymore. I don't need to think anymore because somebody's already got the answer. So I have a solution. This one is a little bit trickier to establish, but once established, so important. So I have a solution and I can tell you the strategy I use to get to that solution. You can add more fingers for those students who want to challenge themselves. Can they come up with more than one strategy? Is there another way that they can get that same answer? And during the middle of the number talk, you might use this hand signal to indicate agreement rather than asking for a verbal agreement. So those work beautifully to facilitate and manage those fraction talks. I'm going to show you a number of models that you could use today in a number of grades. I want to highlight them here very quickly for you because they all matter when learning about fractions. Students should have experiences with set models such as counters or collections. With area models, yes, that pizza model is an area model. The chocolate bar is an area model. But we also want to use tools like these where we can layer and stack pieces on top of each other like the pattern blocks. The third model that students should all have experience with is a length model. And now that schools have Cuisenaire rods, that's a beautiful tool that you can use for this. You can also create paper strips, which helps students to own that thinking, and they can write right on those paper strips as a tool for thinking and reasoning with. You may also want to access some digital resources when you're modeling on the smartboard, such as these ones that you can see through Mathagon or Didax, including even a geoboard for another version of that area model. For older students, they could even do some of their reasoning with these digital tools, depending on your access and availability. Here's a sample fraction talk that you might do with grade 1 students who are starting to learn about the 1/2 part whole relationship. And so you might pose an image like this, and you might ask the question, I want to share half of my cookies with my friend Meredith. Can you see 1/2 of the whole? How do you see it? And so now you give students that thinking time, so they're thinking, they see 1/2, they can tell you how they see it. Now you can be circling on your smartboard to represent the different ways of thinking. Perhaps you could use some images like this to help support thinking if needed. So the two-sided counters can show, I can see 2 on one side, 2 on the other side. Those are equal halves. Those are the same. Or maybe they see 2 on the top and 2 on the bottom. Half on top, half on the bottom. I think this is half because it's both 2 and they are the same. This model can be used very easily in both grade 1 and 2. In grade 1, we're describing a group as 1/2. They do not need to write it symbolically at this point. Grade 2, they might be comparing different unit fractions of the same whole, limited to denominators of 10 or less. And an additional thing that you might want to do is actually give students counters that they can manipulate. So as they are trying to determine what is half, they're working with it. So during that thinking time, they might be using manipulatives. You might start with a simple problem like this that gives all students access, and then show increasingly complex situations as well. So what that might look like is changing what the sets look So of course you could change quantities, but you might also change so that there are multiple colors. What would half look like? Different shapes, different arrangements, different sizes. And so students need to be able to recognize that 1/2 can be any of the parts that equal 1/2 of the set. And that's a little bit of a tricky concept, especially when we get to the different sized circles. So I could separate those different size circles as one small, one medium, one large in each half, because I'm also attending to size, but I don't need to. I could take these 3 on one side as half and these 3 on the other side as half, because I'm not considering it an area model now. I'm considering it a count, a set. So what is 1/2 of the set? 3 is 1/2 of that set. So you may find these prompts helpful, especially when you're trying to avoid that tell and you're trying to continue to ask questions to drive thinking. Asking a question like, who would like to defend this answer? That's part of that math debate. But just because one student has provided that solution doesn't mean that another student can't provide the strategy for that solution. Getting students to actually draw when they're struggling to find the words, while we do want it to be mental math and we're striving for students to be able to articulate their reasoning, that might be a tool some students would require in order to share their thinking and participate. How did you know that? Does anyone else think they can explain? And of course, that opportunity to turn and talk, especially in the beginning of number talks. I find that so valuable because it gives students that chance to rehearse their answer before they actually share it out with the larger group. So now I'm moving on to an area model, and this one starts with just a visual prompt. This one comes from Math for Love, where they have a number of these area models ready to go, and they also have a second series, their pattern block edition. So they have lots of visuals that you can select from. So going back to that purposeful problems, this might be an earlier one that you could use with, say, a grade 3 or a grade 4 class. And the question begins with, what fraction is each color of the whole? And so what you might be asking students to do is concentrate on just one color at first. So maybe they're going to pick the red and name the fraction, the relationship between the red and fraction and the whole shape, the whole larger rectangle. Maybe they'll choose green, maybe they'll choose blue. So again, we have our thinking time. Maybe we're going to commit to a name for red. Maybe we can explain our thinking, and then we go ahead and start sharing. And so students might share the following solutions here. Sorry, my mouse is not working. Let's see if I can get that working. There we go. So you might see these, and you're recording them right on the shape. So you're recording 1/2 on the red, 1/8 on the blue. 2 solutions are shared for the green. So one student says 3/4, another one says 3/8. And one of the key parts of a number talk or a fraction talk is asking, are there any other solutions? And so in this situation, in this imaginary example, 2 solutions are provided for the green. We accept all solutions. So then we move on to the strategies. So how did you determine that the red was 1/2? What strategy did you use? How do you know that 1/8 is, or what made you think that the blue was 1/8, and so on? So those are some of the questions that you might ask. And then as students are explaining, you might be modeling by drawing the lines, by showing how their thinking is shown by adding those horizontal and vertical lines. And then notice that an additional fraction has been added. because a student might see this representation and go, well, isn't the red 4/8? So now there's another opportunity for that discussion. And while in grade 3 we may not be focusing on equivalent fractions, it would be an interesting conversation. And in grade 4, this is a great way to introduce that concept of equivalent fractions. And now we might be able to go back to that 3/4 and that 3/8 and have students defend one or the other, and then hopefully come to a consensus. But we don't always have to come to a consensus. We can come back to these again at another time. Additionally, thinking of grade 4, as we're thinking of equivalent fractions, you might ask students to think of whether or not they can think of another expression that would be equivalent to the ones that are already shared, and they might do so by adding additional lines to get a higher term. Okay, so this is an example of the pattern block addition from Math for Love. Sorry about that. I accidentally clicked on something that's hidden in the background. There we go. I think we're ready for it. So just a photograph, easy to create, but again, there are a number of these ready to go on the Math for Love website. And so when we're looking at the whole image includes all of the yellow, blue, and green shapes that we see here. Same idea. What fraction is each color of the whole? And you may want to consider providing students with some sentence stems for their reasoning as they go through this. So the yellow is a certain fraction of the whole, the blue is a certain fraction of the whole, and so on. What you can do then is, as students are thinking through and they're selecting just that one color, you can be drawing right on your smartboard to draw over top of these images. So, or if you're using your document camera and you have this set up with your document camera, you can be laying the shapes on top. And so as students express, for example, that the blue might be 2/12 of the whole, and then you're asking, does anyone have a strategy for how we could show whether or not this is 2/12? Well, they talk about putting blue tiles, pattern blocks, on top of the yellow. 3 of those fit on each yellow. So 3 plus 3 plus 3 is 9. And then the 2 blue is 11. And then the 2 green are equal to one of the blues, so that's 12. So they're 2/12 of the whole. And you can be drawing or modeling using your document camera with the students to show those. Sometimes you're going to want to pose a statement that doesn't start with a visual, because in our new curriculum, already beginning in grade 3, students are need to determine where fractional amounts fit in relation to some benchmark numbers. So these are the benchmark numbers for grade 3, 0, 1/2, or 1 whole. Trying to figure out where 3/8 fits, as though it were on a number line, may need some time to develop. And so what you could do in this situation is pose a question like this. We still go through with the hand routines, but you can give students tools so that they can be working through this still mentally, but they might want to be using, say, a mini whiteboard and a dry erase marker, paper and pencil, maybe some tools as they work through this problem. And so the question I have is, what tools could students use to model this? And how could you support students communicating their thinking on this? Here's some tips for the classroom that I just want you to keep in the back of your mind as you're doing these in your class. So again, starting with something that's accessible for everyone, making sure that the strategies are the key piece, not so much what the solution is, but how you got there. Supporting students in using that really constructive language. I respectfully disagree because, or I agree with Sam because. always keeping that environment safe, keeping it positive, thanking students for their contributions, and trying to keep it short. The first couple times that you do it, it's not going to be 5 to 10 minutes. It's probably going to be more like 20 minutes. But if you do this regularly and you can get to that 5 to 10 minutes, it can be an opener to your day that's not even part of your math block. And yet you're continuing to make this powerful routine live on a regular basis. So now we're going to move into some of the operations with fractions that could also be done as part of a number talk. So multiplication with fractions does not occur until grade 6. But that being said, this is a good example and could be used with addition of fractions that occur in earlier grades. So it's part of what we call a number string. We're going to pose one question, give students some time to think through it, pose a second question that's related, and then pose a third question where you take what you've learned from the first and the second question and apply it to the third. So in this instance, we're thinking of 1/4 times 3. So we're trying to help students thinking about that we're actually going to have 3 1/4 units. So what tool could students use to support this? Maybe they're going to use Cuisenaire rods. Now we're moving into that length model. And so in order to show fourths, they might select the brown rod, knowing that 4 red rods would represent those fourths within that red rod. And then they're actually doing 3 times that 1/4. So 1 1/4, 2 1/4, 3 1/4. That is the response for that one. So then they move into this one. So 3 half units is equal to, what would that be? And then they get to the final part of the string. If they know 1/4, 3 1/4, and then they know 3 1/2, how can they use that to solve 3 3/4 by combining those and using the properties that they have learned in regular multiplication with whole numbers? Here is another model where we can see this number string expanded. So we can see the 3 1/4, we can see the 3 1/2, and when you combine 3 1/4 and 3 1/2, we have our final response, which if students need support, they can count through by iterating. So 1 1/4, 2 1/4, 3 1/4, 4 1/4, and so on. Also keeping in mind the number of holes that this creates. So we can see that this creates 2 holes and 1/4 left in addition to the 2 holes. So we could read this as a mixed numeral or an improper fraction using this model to support. And so this Cuisenaire environment has been linked as well as another place where students can model and record their thinking. And we just wanted to highlight, as we mentioned before, that there's single point rubrics are a great tool where you can collect some of this information, in particular collecting that conversation piece, but you will also observe if students are working with materials. You can collect photos of what they're doing as you go and of strategies. In our slide deck, we have linked all of the single point rubrics for all of the grades where fractions begin in grade 1. So you can find that here. And we have just included those number talk essentials, a lot of which we've already talked about through this process, just to keep in the back of your mind as you begin planning with these. We have a few videos linked here that you can use as background information for yourself. All of these are examples that can help you see it again, the routine in action to support your professional growth. And finally, we have a number of Fraction Talk websites full of ideas that can support you as you're selecting and finding ones that fit your students. While the Number Talk images in the bottom left from Kristen Acosta are designed for number talks, they often also beautifully work with fraction talks, as you can see from that image of eggs. So hopefully with all of these resources, you can find some ready to use ones for your classroom. And thank you for joining. I hope this was valuable. And of course, if you ever have questions, you don't need to reach out just to myself or just to Meredith. Please connect with your elementary math consultant, and they can even come out and help support you with getting your fraction talks or number talks started. We will have one more session coming up in April, so watch ECSD events in order to register. Thanks and have a great evening.